Year 11, homework 1. If you're watching this, you're possibly stuck on a question. If I were you, I would scan to the question you're stuck on the video rather than watching the whole thing. First question, give a definition of relative atomic mass and give a definition of isotope. Okay, definitions we just need to learn for the exam. If you learn them and the question's there, you'll get the marks, and if you haven't learned them, you won't. You just need to learn them. So if you don't know these, don't panic right now. The place to find them is the glossary. So if you go to the front of your book, okay, I've got a year 10 book here. I know this is year 11 homework, but there's a glossary in here as well. If you go to the glossary, so in the book you're working in, find the glossary and the section there. Okay, so section 3 is the glossary in that book. So have a look at the front page of yours, find the glossary. It's a dictionary of all science terms. Okay, here's relative atomic mass. There's the definition. It just needs writing out. Okay, and then it needs learning. So write it out 5 times if I were you, if you haven't learned it, and then get your folks to test you on it later. Same with isotope, get those learned. Next question. Complete the following table showing numbers of subatomic particles. A subatomic particle is a proton, a neutron, or an electron. In magnesium and its isotopes, magnesium has an atomic number of 12. Okay, well, I'm not going to do this for magnesium. I'm going to do it for carbon. Carbon has an atomic number, okay, of 6. And I'm going to tell you there's 2 carbon isotopes, carbon 12 and carbon 14. Okay, now an atomic number of 6 means it has a proton number of 6. So if you look on the periodic table, carbon will be written like that. Okay, so you can put that 12 down there, can't you? Okay, so if it's got an atomic number of 6, a proton number of 6, it has 6 protons. Both of those have 6 protons. Okay, now protons are positively charged. Atoms of elements are neutrally charged. So if it has 6 positive charges, it must have 6 negative charges. Okay, must have 6 negative charges. Now, the particle that is negatively charged is the electron. Okay, so this bottom number here tells us the number of protons and the number of electrons. Now, last one, the neutrons, because we've done protons and electrons. The neutrons. The neutrons are worked out by using the mass number and the atomic number together. Now, the mass number, let's talk about that. Mass number is the number of protons and neutrons combined. So not 12 of each, but 12 in total. So these two added together add up to 12. Now we know there's 6 protons, okay? So we know 6 protons, so we need to do 12 minus 6, which is 6. So 6 neutrons. 6 and 6 is 12. Those two together equals 12. We take the bottom number from the top number for the number of neutrons, 6 neutrons. Over here, 14 protons and neutrons in total, not of both, but in total. We know there's 6 protons, so 14 minus 6 is 8. 8 and 6 is 14. So that's going to be 14 minus 6 equals 8 neutrons. Okay, so that's what you need to do for those ones. Next one down here. A sample of lithium contains 10% lithium-6. This is not lithium minus 6, this is a mass number. Lithium, we just write mass numbers like that, lithium-6. So that atom of lithium has a mass number of 6, that's what that tells us. And this sample of lithium contains 90% of lithium-7. So what we're saying here is this sample of lithium is made up of 2 isotopes. Remember, an isotope, atoms of the same element, same number of protons, different number of neutrons. So naturally occurring lithium is made of 2 different atoms of lithium. Okay, and there's 10% of that one and 90% of that one. Okay, and what we need to do is work out the relative atomic mass, which is the average mass of all those atoms. Okay, so the average between 6 and 7 has to be somewhere between 6 and 7, doesn't it? So if you get an answer that isn't between 6 and 7, because this is an average, it's wrong. Okay, so to do this, now we did this in year 10, okay, it's part of the topic 1, so that's why I've got a year 10 workbook here today. It's part of the topic 1, which is the key concepts in chemistry, okay. That topic 1 is examined on both papers, that's why we're revising it. That's why we're revising it here. So if you want to go back to year 10 book, that's fine. There's also a video about it as well, which you can have a read up on later. But the important thing is this formula here. Okay, this formula here. Okay, and then there's a worked example, which you can do here. So let's just imagine I'm doing this worked example, okay, in this one here. So I'm not answering this question, so don't copy this. Okay, but this one says naturally occurring chlorines comprise 75% chlorine 35 and 25% chlorine 37. So I'm going to do that one, okay? So the first thing we need to do is this formula. Percentage times mass plus percentage times mass. Now, you need a percentage times mass for each isotope. In this question, there's 2 isotopes, so you need 2 of those. Okay. In this question here, there was 2 isotopes, so we need 2 of those. Okay. And we divide that by 100, and that's what we need to do. So we said 75% multiplied by, and it was chlorine 35. 75% of chlorine 35, 25% of chlorine 37. 75% mass chlorine 35 plus 25% multiplied by chlorine 37 divided by 100. Now, these brackets we have to work out first. All right, so get your calculator, and we're going to do, for this example, 75 times 35. 75 times 35, and we press equals. 2625, so let's write 2625 down there. Okay, plus, and now, next bit, cancel that off completely. 25 times 37. 25 times 37. 925. Plus 925, write it down. Divided by 100. Okay, so now we're going to work that out. Okay, it was 2625. 2625 plus 925 equals 3550 divided by 100. And that is 35.5 equals 35.5. Now that is not the answer to your homework, so don't copy it. That's just a different example to see how to do it. You need to do that with lithium. 10% lithium 6 and 90% lithium 7. Notice the answer 35.5 is the average of chlorine 35 and chlorine 37 in this case. So the answer is between 35 and 37, 35.5. Okay, your answer has to be between 6 and 7. Next question for your homework. Okay, a sample of titanium contains, and this time we've got 5 isotopes. So a moment ago, when we did that calculation with 2 percentage times mass, you're going to need another 3 of those, plus percentage times mass, plus percentage. So we just need one of these percentage times mass for each isotope, yeah? Plus percentage, you get the idea, times mass. So you just do that 5 times, okay, for each of those. Now again, the masses are between 46 and 50, so the answer has to be between 46 and 50. Now looking at these numbers, okay, the answer is going to be around 74. Sorry, 74. The answer is going to be around 48, the middle one, because most of the titanium atoms have a mass of 48. 74% have a mass of 48, so the answer is going to be about 48. But I want to know maybe to a couple of decimal places. I haven't specified how many, but let's do it to a couple of decimal places if you're not sure. If you do that, then you'll get all that homework right. And if you can do all those questions, okay, then you're easily on for higher tier chemistry. Good luck.